Okay, here we go. Next example, example 4. It takes on average 21.75 seconds for a lab rat to complete a task. Placed in a different environment, a random sample of 50 times was taken to complete the task. The data was recorded and it was summarised in the figures we have here. The sum of the times and the sum of the squares of the times. Test at the 5% level whether the new environment has changed the mean time to complete the task. Why is this example in my notes? What is different here?
You have to work out.
You've got sigma t and sigma t squared.
As opposed to...
just being given the distribution.
Yeah, that's right. We don't have the population parameters here. Okay, so in this example here, we don't have the population mean and variance. So that is the key difference here. What we have instead is we have summary data. So we have summary data from our sample. So, what's the implication of that?
You have to work it out ourselves.
Work what out?
Mu and sigma squared.
Using what technique, process? Unbiased estimators, yeah. So we will need to use unbiased estimators somewhere in this question. Okay. So, that's why this question is in here. So, let's go back to the beginning first of all, and we'll work those things out as we need to go through. So, step 1 was come up with your hypotheses. So step 1, null hypothesis. Well, let's look at the question. It says, test at the 5% level whether the new environment has changed the mean time. So the null hypothesis is the mean has not changed. Mu is still 21.75 that we are told. The alternative hypothesis, H1, it says test whether it has changed. So the mean has changed. So what will I write down in stats language for that?
Mu does not equal 21.75.
Yeah, does not equal. It's not greater than or equal to, it's just has it changed. And as soon as I write my alternative hypothesis down, what else am I usually writing? Well, always writing down at that point. Yeah, this is a two-tail test.
Do you get a mark for that?
We'll look at some mark schemes. We will look at some real A-level questions with some mark schemes. Right, step 2. Decide on the significance level of the test. We're told it's 5% significance level that we're using. At this point, this is when I decide I'm going to draw a diagram. Then I can work out sort of where I'm heading and what I'm doing. Under my null hypothesis, mu is 21.75. It's a two-tail test, so I'm interested in tails at either side, and those tails together have got to add up to 5%. So each tail is going to have 2.5% in it, which means I'm going to have two critical values, critical value 1 on the left, critical value 2 on the right. And if my sample statistic, my sample mean is in one of those tails, I will reject H0 and accept H1. If my sample mean is in the white bit in the middle, the clear bit, then I will stick with H0. So, I've got to do my calculation next. So for my calculation, I need to know the distribution that I'm using. So we're talking about time and a sample of time. So what I need now is the distribution of T bar. Normally distributed. Mu, I don't know what that is, so I'll have to use mu hat. And sigma squared over n, well I don't know what sigma squared is, so I have to use sigma hat. Sigma squared hat there as well. Actually, I said one thing there that's incorrect. Sorry? Yeah, under the null hypothesis, we know that mu is 21.75. So yeah, actually don't need to work out mu hat. I am going to work on the basis of that's 21.75 in there, because that's what my null hypothesis says. So actually I don't need mu hat. What I need is sigma squared hat. So can somebody tell me the formula for sigma squared hat, an unbiased estimator of the variance?
N over n minus 1 sigma t squared over n minus sigma q squared.
Yeah, okay. It's n minus n over n minus 1 of the sample variance, and that's what you were telling me. The sample variance is sigma t squared over n minus t bar squared. And that t bar is add up all the t's and divide by how many there are. So in the question, we were given sigma t squared, we were given sigma t, we know what n is 50. So if we now work those out, we'll get, substitute into all of those three formulas, if you want to do it in steps, we should find out our value for sigma squared hat. So I'm just going to pause the video at this point, see if you can work out sigma squared hat.